All right, I think we will get started. I think most people are here. So, okay, so hopefully everyone can see my screen. All right, so good morning to our team leaders, jurors, student participants, members of the CaYPT organizing committee, and our special guest, Professor David Bailey and Dr. Sasha Nikovich. I would like to welcome you to the 5th Canadian Young Physicists Tournament 2021. As we all know, the past year have been an unusual year. Lots of things have changed. But I'm pleased to say that thanks to the perseverance, the compassion, and the ingenuity of the organizing committee and our partners, we're able to adapt to this new style of competition. And I'm thrilled to announce that this year we have 12 participating teams, and we have grown to an event of more than 100 people, at least in our system. But not 100 people are here, but hopefully we'll be seeing them at the physics matches. So let us introduce our teams this year. So when I call out your team's name, I want your team captain to just say hi to everyone, introduce the team members of your team, and we'll go by the order of registration. So firstly, we have team SMUS from St. Michael's University School, Victoria, BC. And could the team captain introduce your team?
Hello, everyone. This is Zach. On our team, we have 5 members, Felix, Jay, Joshua, and Fa. We're, I guess, the first BC school to join CaYPT.
Cool. And next, we have Team Schwarz Children. They are an independent team, which I gave them this cool independent logo. And could their team captain introduce their team?
Sorry. Hello, everyone. We're Team Schwarz Children. We have 5 people on our team. Yeah, great. We're here.
Cool. And next, we have Team Schrodinger's Wildcats. They are from White Oak Secondary School, Oakville, Ontario. Could the team captain introduce their team?
Yes, we are the team Schrodinger's Cats. Yeah, we have 4 team members, Derek, Frank, Julia, and Matthew. Yeah.
Cool, welcome. And next we have Team Terra Quirks from Victoria Park Collegiate Institute, Toronto, Ontario. Could your team captain introduce your team?
Hello, my name is Stone, and on my team I have Dennis, Julia, Sean, and Zainab.
Cool. Next, we have Team Anti-Quirks, also from Victoria Park Collegiate Institute, Toronto, Ontario. Could your team captain introduce your team?
Hi, my name is Shang Sheng, and I'm the team captain. With me on Team Anti-Quarks today, we have Ellen Wang, Aaron Zhang, Kevin Wang, and Faik Faizi.
Awesome, welcome. And next we have Team MGCI Team 1. They're from Margaret Collegiate Institute, North York, Ontario. Could your team captain introduce your team members?
Hello, everyone. My name is Hector, and we have 5 people on our team. So me, Anthony, Enoch, Jackie, and Wenzo.
Cool, welcome. And next we have Team We Who Shall Not Be Named from Abbey Park High School, Oakville, Ontario. Could your team captain introduce your team?
Hi, everyone. I'm Alex, and our team has 5 members, me, Eli, Harry, Luca, and Sam.
Welcome. Next, we have Team Perturbation from McKinney Secondary School, Scarborough, Ontario. Could your team captain introduce your team?
Hi, my name is Ursher. We are Team Perturbation. We have me, George, Emi or Andy, and ZU.
Welcome. And next we have Team Epsilon from University of Toronto Schools, Toronto, Ontario. Could your team captain introduce your team?
Hi, my name is Martin Zhao. I'm the team captain, and joining me today are Ali, Alan, Crystal, and Harry.
Welcome. Next, we have Team Theta, also from University of Toronto Schools, Toronto, Ontario. Could your team captain introduce your team?
Okay, hi. I'm Adrian, and on our team we have Archie Xu, Braden Zhang, Emily Xu, and Sophia Wang.
Welcome. Next, we have, oops, forgot to change your name from the previous slides, but I believe your team name is Team Sigma, right? And could your team captain introduce your team?
Yeah, hi, my name is Daniel, and here with us on Team Sigma, we have John, Abe, Shuyu, and Clay.
Welcome. And last but not least, we have Team Lonsdale from Upper Canada College, Toronto, Ontario. Could your team captain introduce your team?
So hi, my name is Steven, and in my team we also have Alan Su, Alexander Chow, Nicholas Wu, and Raymond Liu.
All right, thank you guys. So next, let us welcome our first guest speaker, Professor David Bailey. Professor Bailey is a professor of physics at the University of Toronto that specializes in experimental particle physics and physics education. He is the chair of the U of T Physics Department Outreach Committee and also a member of the CaYPT Problem Selection Committee. Professor Bailey and the U of T Physics Department have been extremely supportive of CaYPT since our first tournament. So I'm going to stop screen sharing and we'll pass it to Professor Bailey.
So, thank you. You can hear me?
Yep.
Oh, good. Okay. I'd like to welcome everyone to CaYPT 2021 again. I'm sad that this year we can't host you in person, but I certainly hope that in future we will see many of you at the University of Toronto as students or just as visitors. And in this contest, I think you've been learning something about the difference between scientists and most people. I mean, there's this classic XKCD cartoon which shows somebody pulling a lever and getting hit by a lightning bolt. And most people after that situation, they might think for a minute or two, but then they would probably say, I guess I shouldn't do that. I shouldn't pull that lever again. But if you're a scientist, your immediate reaction is, why did that happen? I wonder if I pull it again, will it happen again? Of course, maybe that's why there aren't so many scientists. But this also characterizes, physicists, scientists in general are curious and we're easily distracted. And this is why many physicists drink their coffee cold, because if you give us a cup of coffee, we're liable to get distracted. I mean, there's this famous paper from 1997, which was started by some scientists looking at their spilled coffee and noticing, as many people have before, that when it dries, it forms this ring. It doesn't just dry uniformly. And many people have seen this over the years, but these physicists said, there's got to be a reason for this. And they wrote this paper, Capillary Flow as the Cause of Ring Stains from Dried Liquid Drops in Nature, which is perhaps science's leading journal. And this turned out to be a very significant paper. Last time I checked, like yesterday, it had like 5,000 citations. This had a lot of impact in a lot of areas. But of course, physicists don't stop there. Other physicists, when they walk with your coffee, you notice that it's hard not to spill it. So they write a paper trying to figure out why. Walking with coffee, why does it spill? And of course, once you notice that some coffee spills, you notice that other coffee doesn't spill so much. In fact, if you drink a latte, the foam on top actually makes a difference. So you try and figure out why, and you write a paper, Damping of Liquid Sloshing by Foams. And if you're drinking coffee, lattes, you're going to start looking at it in more detail, especially if you have a glass cup. And you notice it forms layers and say, why does that happen? Another paper, Laboratory Layered Latte. But of course, the original coffee ring paper isn't forgotten. And those physicists who drink their coffee sweeter notice the stains look different. So they investigate and they discover that sugar suppresses coffee rings. Another paper. But then other physicists who decide don't like their coffee sweet discover that you can control the rings with salt as well. And this, this last one was actually written by people who are interested in things like inkjet printers. It turns out the copy ring effect, one reason it has those 5,000 citations from the original papers, because it's relevant for lots of applied physics. But anyways, but when you go through all this stuff, by the time you've done all the experiments, your coffee is really, really cold. But all this sort of exemplifies what physicists do and what you've been doing in this contest, right? You've been making measurements, doing experiments in some physical system. And if we understand the system, we should be able to predict its behavior. And you've been trying to do that, I'm sure, with some of these questions. And if the predictions are correct, it makes us more confident in our understanding, but we're never certain. There's always new wrinkles and problems and issues. And if our predictions are wrong, as I'm sure happens sometimes during your experiments, we learn something new. Yeah. And all this is helping you learn how really science is really done. Because often when you talk about science, you'll hear about, somebody proposes to do a measurement or do some theoretical study, and it sounds very straightforward. You're going to take our knowledge from sort of point A to point B. But when you actually do the research, this is what it actually looks like. You go in many wrong directions, things don't work, you have to go back. It takes years. I remember I once worked with a graduate student who was doing a measurement, and in order to get the measurement, they needed to get 10 things working simultaneously. And for 5 years, they could get up to like 9 of the things working, but it took 6 years to get to the point where all 10 worked and they could get their PhD. It is challenging. And of course, once it's all done, if you just look in the journal articles, the way it's described, a few of the wrinkles are in there, but mostly it still sounds pretty straightforward. And actually what bothers me most is that when it gets into a textbook, you'll see a line in one of your textbooks, and that line took 100 physicists all their lives to produce the knowledge that is in that one line. But all that complexity is invisible. And then when you're studying, you think, and if you find it challenging, you say, why is it so hard for me? It's, they present it as if it's obvious. No, it wasn't obvious to the people who discovered it the first time. It was really, really tough. It's only in hindsight after years of effort and, that we can present it in the synthesis that makes it look obvious, but it's not obvious. Now, the other thing you've learned here, I hope, is that it takes a team to do an experiment, right? I mean, your teams are relatively small, and some science is done in relatively small teams, but other science, like the kind I do, often, requires teams of thousands of people. I mean, science is not just sitting around thinking deep thoughts and pondering the mysteries of the universe. You have to get out there and do stuff, and it requires a huge team of people to gather all the knowledge that we have today. Now, some of the experiments, as I mentioned, are large and complicated, like the Atlas experiment, which I've worked on. We study the universe's basic building blocks and forces, and this requires, billions of dollars and thousands of people. Some research is important, like climate change. Here, a lot of physicists at the University of Toronto study climate change and atmospheric pollution, and this can be very complicated, requiring trips up to labs in the Arctic or satellites. But sometimes it's a lot simpler. In the bottom here, you can see one of our graduate students, actually just outside the physics department, towing a little trailer which has a atmospheric spectrometer on it that it's actually neat. When they're going around the city of Toronto, there's actually a little app that you can follow them, and you can see what the carbon monoxide pollution level is at a specific street corner. But again, some experiments are just fun. This is a film made by Stephen Morris, one of our professors, who studies many interesting things. This is icicles. And icicles are something we all see. It's like coffee stains, but what's actually going on there? In particular, in some of these icicles, they have these little ripples, but some of them don't have ripples. Why is that? It turns out to be really, really subtle. It depends on really, trace pollutants and stuff in the water in order to understand this. But even though this is done, Stephen Morris did this just because it was fun. He had his graduate student, very small team. It's still important. Understanding icicles, helping to understand things like, what happens when you have an ice storm. And for example, Professor Morris has been invited to conferences by electrical power utilities because they really care about what happens when ice forms on their lines and things like this. So something that starts with fun could turn into something that's very useful. But again, it all starts with curiosity, a willingness to take chances, make mistakes, get messy, as Ms. Frizzle from the Magic School Bus always said. And I hope you have a really great tournament and have lots of fun. So thanks for participating, and thanks to the CaYPT team for organizing all this. Thank you.
Thank you, Professor Bailey, for the amazing and inspiring speech. let us also welcome our second guest speaker, Dr. Sasha Nikovich. Dr. Nikovich is the founder and president of STEM Fellowship, our parent organization, the parent organization of CaYPT. STEM Fellowship is a student-run Canadian charity organization that uses mentorship and experimental learning to equip the next generation of change makers with indispensable skills in data science and scholarly writing. Dr. N is a data science and interdisciplinary education expert and innovator. Let us welcome Dr. N.
Good morning, everybody. If it is well, it is definitely a morning for even, I believe we have one team from the West Coast. It is really early morning for them. So greetings, participants of the 21st Canadian Young Physicists Tournament. As a founder and president of STEM Fellowship, the National Students Digital Scholarly Society, built on the principles of open science, I welcome you to our flagship inquiry program. STEM, CaYPT takes physics and math education to the next level. It offers student agency and research on top of traditional high school pedagogical resources and methods. The program is unique learning exercise in experiment setup and scientific method that is combined with scholarly presentation and peer review of findings. It is also a great opportunity to develop research collaboration and teamwork skills critical in the knowledge-based economy. I wish good luck to every team and look forward to seeing your proofs and hearing arguments and counter-arguments. I also invite you to visit STEM Fellowship website and consider participating in high school or university Big Data Challenges. This year, University Big Data Challenge is on the infodemics. So look up, we have even actually Professor Günther Esenbach, who coined this term, and one of the lead medical doctor, and it is very interesting, and publish your research in open access, NRC Research Press, STEM Fellowship Journal. So if your participation in CaYPT will lead you to original research, we are open and we'll be happy to help you to take your research and in preparation for the scholarly manuscript. I also want to thank all the judges, and I want to thank all the organizers for their great work in preparation and taking this program to fruition. Thank you.
Thank you so much, Dr. N. And the next stage of our opening ceremony will be the team draw. And just give me a moment as I set this up for everyone. So essentially, for the team draw, what we're going to do is that in our CaYPT management system on caypt.org, we have the system where we actually will automatically do a scheduling of the teams to the rooms and the jurors to the rooms. And I will just take a moment to launch that. Just give me a second. Hopefully everyone can see my screen right now. So we will proceed to plan selective matches. So this time we have 12 teams. We have 6 rooms in total, and we will generate a plan. So as you can see, our plan here is generated. We have just the team 1 to team 12. These teams are not associated with any particular team yet. So what is going to happen is that I will actually show my camera, And behind me, hopefully everyone can see it. Behind me, I have, well, I'll move my chair. I have, let me adjust my camera slightly. Hopefully this will be the right location. And focus it. We have 12 equations. Okay, so the first task of the teams and the team captains will be to actually choose one of these equations, and behind each one of these cards there is a number. Okay, and that number will correspond to team in our management system. All right. So again, by the order of registration, we should invite, I believe, Team SMUS to choose one equation card. So could the team captain of Team SMUS choose one of these equations? I hope you guys can see it clearly.
Yeah, I would like to choose F is equal to MA.
Wow. Okay, fundamental, yes. So we'll take this out, hopefully without revealing the other cards. And you get the number 11. All right, so I will make a note of that. 11, so you are team 11, and I will put that into our system. All right, so next we will have Team Schwartz children, and please choose one of these equations.
We choose E equals HF.
Okay, so you choose our photon energy, cool, and you get your team 8. Okay, my image looks a little dark, but that's okay. You guys are Team Schwartz children independent. All right, so next we have Team Schrodinger's Wildcats. Please choose an equation.
Yeah, where's the equation cards? Where are the equation cards?
I'm showing it on my video, so you could just look at my video.
Yeah, it's too tiny. So sorry, wait a second.
Yeah, no worries.
Okay, so E equal to MC squared.
E equals MC squared?
Yeah.
This one, all right. Oh. So just to answer a few questions in chat right now. Okay. Take E equals MC squared out. And you guys get number 1. So you guys are Team Schrodinger's Wildcats, and you are 1. All right. So next we have Team Tetraquarks.
Can I choose the first law of thermodynamics?
First law of thermodynamics. Here we go. Okay, and you get team number 6. Team number 6, and you are Tetraquarks. Yes. Next, Team Antiquarks.
The equation in the top right.
Top right. So Faraday's law, or the curl of E. Cool. And you get number 10. So we have number 10 is Antiquarks, correct. Next, we have Team MGCI Team 1.
The one in the bottom left.
Bottom left, entropy. Entropy. So you get number 4. You are 1. All right. Next, we have team we who shall not be named.
We'll go with the bottom one.
Bottom one. So Schrodinger's equation. Okay. Cool. We have number 12. Number 12. You get named. Okay. Next, we have team perturbation.
Can we have Fg equals to G m1 m2 over r squared?
Okay. It seems like Maxwell's equations are not quite favorable amongst the teams. You get number 3. You guys are perturbation, correct? Team epsilon.
I would like to represent my team's uncertainty with Heisenberg's uncertainty principle.
All right, Heisenberg's uncertainty principle. You get number 2. Your team epsilon. All right. Next, we have team theta.
Can we choose the one on the right?
One on the right. So Gauss's law. Cool. You get number 7. Number 7, you are team theta. And then next we have team sigma.
We'll take Gauss's law for magnetism.
Okay. And you get number 5. And now the last team, make a choice. So you guys should get, this is the Ampere's law with Maxwell's corrections, the longest one. So you get number 9. Okay, and you are on step. All right, I think we are settled. All right, hopefully everyone can still see my screen. And now we will accept team assignment and finalize plan. So before I do that, can everyone see this? And does everyone confirm that my placement of the teams are correct? No, team 11 is SMUS. It's default to the first team. Because in fact, all of them defaulted to the first team. All right, everyone making sure it's correct. Hopefully, no objections. Okay, we'll just accept team assignment and finalize plan. Okay, this generates this plan which only we can understand, but a more easy to read version will be available to you guys very soon. So we will just click yes and submit. And this is plan number 3 proposed. We will, seems like everyone's fine. And seems like, all right. Seems like everything works fine. So for this bottom chart, this will be available on the homepage of CaYPT.org. And you can just follow your team, follow it down a column, and you'll be able to see which room you're in for each one of the rounds. And then this is the juror schedule, which will also be available on the homepage. I will accept and activate the plan. So now the plan has been successfully activated, and hopefully if I go back to home, we will be able to see the entire schedule. And then, yeah, so we have round 1, round 2, round 3, round 4, round 5, and then finals coming soon. Yep. So, hopefully you guys will be able to use this. We will actually take a bit of time to actually put this into a chart as well. And then we'll be emailing it to everyone just to make sure that we have multiple copies and there's no confusions there. Do we have any questions about the draw process? hopefully not. And I will. Okay. So okay. So now I will go back. So just you guys should give us a bit of time as we send this out to everyone. So meanwhile, I'm going to stop this share, and I will share my PowerPoint slides again. And I had prepared this meme for you guys. So enjoy the meme while we send the schedule to everyone, okay? Give us about 10 minutes or so.
Hi, Jim. It's Neil.
Yes.
Yeah, I see the schedule now. Do you still need me here? Can I move on to my room C?
Cool, but those rooms, I'm just not sure whether our volunteers are there yet. You can try to join the rooms, but
I'll
you
wait
might
then. I'll wait then.
need to wait for a bit.
Okay, no worries.
I would like to ask teams to not leave at the moment, because we will still be making some important announcements later on. So hopefully our schedule should be sent out to everyone. I will also add this to the documents channel of our Discord server. So for everyone that's on Discord, you guys can take a look. All right. So yes, so that everyone should have a plan. If you guys have any questions, feel free to email us. So let me resume the share. All right. So I have actually just a few announcements to make. So before today, we have been receiving a few emails about how we are actually going to deal with partial student absence. So what I mean by that is students absent for like one of the 2 days. And hopefully this will not apply to any of the teams, but here are the policies that we have set out. So one is that the students that is absent for any one of the 2 days, will not receive a medal, only participation certificate, and the rest of the team is unaffected. Okay. The student will still be eligible for individual selections later on down the line, and will still be eligible to participate in CaYPT National Camp if they pass the individual selection stage. And teams that have less than 3 members will not be eligible for the final match. So that is when we get to the stage where we have the final match. If a team made it to the final, but they have less than 3 people that will join the final match, they will not be allowed to participate in that. And if that's the case, then their maximum ranking will be 4th place. Okay, because the top 3 places are the final physics match participants. And this policy will be added to the 2020 edition of the CaYPT rules, and it will be added to the 2022 edition of the CaYPT rules and regulations. And another thing is some policies regarding recording or streaming the physics matches. So recording and streaming will be prohibited. The CaYPT committee will record all of the physics matches and may release the recording on our YouTube channel later on, possibly after this year's IYPT have been completed. So the team leaders, the non-judging team leaders, are permitted to join any other PM rooms, but they must clearly state their identity to the participant of that PM room. All right. And the final physics match will be live streamed on YouTube. And this policy will also be added to the 2022 edition of the CaYPT rules and regulations. So the plans are settled. And I just want to give some concluding remarks. So for all of you, the young physicists, now it is your time to shine. And my experiences as a past participant and also tournament organizer tells me that your creativity never fails to impress us. And I hope that you can enjoy your physics matches. You can collaborate with your peers, be bold, and compete with dignity. Many of us, must stay in our rooms nowadays, but I want you to remember that our minds are always free. And I declare the official opening of the 5th Canadian Young Physicists Tournament 2021. And I look forward to your performances in the physics matches. Thank you. All right. So I'll move on to my last slide. So any questions regarding, how the physics match should go, or just like any questions about our policies in general? Okay, can we explain the procedure for each physics match? So so let me see. Is there someone here in our here that is from our committee? So Ryan needs to judge, I think. So Patrick, if you're still there, can you stay in this room and explain to Matthew about the procedure for each physics match?
Sure. Yeah, I can do that.
Yeah, I'll have to leave to join another room, I believe, and I'll have to coordinate the volunteers as well. So you can just stay in this room and answer any questions. All right? Thank you.
Cool. Sounds good. I will go ahead and do that. So yeah, so in terms of format, the actual format you can find on, I believe, the CaYPT website as well. But essentially, it starts out with you having a challenge. So the opposing team will challenge the reporting team on a certain problem, and you can either accept or reject the challenge. So I believe it's 2 rejections total, right, Jim? We're giving them?
Yeah, so 1 rejection per day, right?
One
So
rejection per
for
day.
each day, we have 5 problems, and you may reject up to 1 without penalty.
Okay, sounds good. Yeah, so basically the reporting team can either accept or reject, and the moment they accept the challenge, then they'll have a little bit of time to get their PowerPoint and stuff ready. And then once the physics match actually starts, the reporter will actually go ahead and do their presentation. Afterwards, what's going to happen is there'll be a small period of time for some questions from the opponent. And then afterwards, what'll happen then is then the opponent will go ahead and do their little presentation. So they'll highlight some of the main, shortcomings or flaws or things they noticed in the presentation. And then afterwards, it'll open the floor for a reporter opponent discussion. So that'll be a long period of time for both participants to, discuss the physics and go through the details of the fight. And then afterwards, what'll happen is the opponents will have a chance to do their little summary, and then the reporter will have a chance to do their summary. And then both people will be kind of brought to the hot seat to meet the jurors who will ask questions for a period of time. Then afterwards, the jurors will have some time to, deliberate and make their scores. And then basically the entire process will repeat itself with the 2 roles flipped. So yeah, that's your basic idea for a physics match. For the physics fights, for the finals, there will be a 3rd team called the reviewer, which is more in line with what they do at the international competition, but we will discuss that format next week. Zach, we answered your question. 1 problem per day can be rejected.
So I can answer the question from Stone about how do we know which team are reporting first. So as we have, as like it's the same as previous years, where in our system, the room volunteer will do a draw, right? We'll do a draw, and then it will decide in which order the reporting and all position goes. All right. Okay, what if there are technical issues? So technical issues, yeah, so when you guys send messages in the chat, please direct it to everyone. So both me and Patrick can see it. So in terms of technical issues, if you look on our protocol, if you look in the teleconference protocol that we have sent to you sometime back, right? We have outlined what are the cases where like if some technical issues do occur, what we will do with it, right? And if it's a small issue, then hopefully the chair of the room, the chair juror of the room will help to resolve that. And he or she has the right to actually give you guys, any amount of like extra time that you might need. So like within reason, right? And but if there's a major problem, please report it to us, and we will follow the protocol. And we might need to do, an extrapolation of your score, or like a scaling of your score based on which parts you have done or you can do. All right. So in terms of timing wise, don't be too stressed about keeping, our schedule like too strictly, because we do have like 1 hour, like 1.5 hour of buffer time, I believe, after the first match. And hopefully that will allow us to sort out all of the issues, right? After the first round, things tend to go more smoothly. And hopefully with the subsequent rounds, there will be less technical issues. Hopefully that answers your questions. Okay, so for the non-team leader members, yes. So non-team leader members join other. No, non-team leader members cannot join other physics matches because you will all be in your room, right? You can't join other people's rooms. Can reporter and opponent be the same person? Yes. Yes, I believe so. But I'll have to pull up the rules and regulations to check real quick, just to make sure that I am sure of it. So quarter and regulation. I believe, yeah. So our rules and regulations section number 7 states that no member of a team may take the floor more than twice during one selective physics match, or as reporter more than 3 times in total during all selective physics matches. During the final physics match, any team member can take the floor only once. And that is the rule. So you can take the floor as reporter and opponent, right? So as long as it is not more than twice, it will be fine. Any questions? Any other questions, rather? So let me just check. Do we have our committee members here? Is any of our committee members here? Like other than like I mean, I guess more specifically our timing volunteers that are here, or Darian, you're here, right? Dave, you're also here. So how is the rooms going? So are you guys able to join those rooms, and then hopefully we can get the matches started?
Good luck, everyone.
Okay, so everyone is okay. So there's some issues with. So for everyone that okay, so if you guys don't have any questions, you can try to make your way to the rooms, and we will get that ready as soon as possible.
I just want to wish everyone good luck.
Good luck, everybody.
How do we join the room? There is a link in the document. I think the document's on the Discord server as well, right, Jim? And that has all the Zoom links you need. Yeah, feel free to leave now and head to your first physics match rooms.
Hello.
Hey, how's it going?
Yeah. All right. So I'm trying to join the room, and it's giving me like the error 1001.
That sounds like a Zoom problem.
It's just to like join on the what's it called on the browser. I do that, and then it says it hasn't started yet.
Oh, that means it hasn't started yet.
Okay.
So
All
Just
right.
kind of wait there, and when the volunteers come to the room, they'll start.
All right.
Yeah, hang tight.
All right. Thanks.
Ryan, are you there?
David, you could head to your room, and it'll say waiting for the host to start. And when it starts, your physics match will begin. So yeah, you can leave this call now and go to your room's call.
We seem to be having issues for the match.
The password's not working.
The password for the room doesn't seem to be working for us.
So which room are you trying to join?
Room C.
Room C. Okay. Room C. Okay. Let me. Okay. Who's the? Okay. Okay. So I will